Now, in this section, we will talk about the limit of function. We're gonna first take a look at the limit of function on the graph first. But define limit and using limit notation. What is limit? Limit is the value that the function output approach at the function input approach. Sometimes they will not necessarily to equal to each other. So the notation of the limit can be written at notation. For example, I want to find the limit or what is the output approach when x approaching to certain number, okay, of that function, and it could be equal to some value. Okay, so limit is actually talk about approaching. It's not exactly at the point, but it's actually what is that approaching to. So let's take a look at example 1. So I have the graph. There's an undefined point at x equal 3 because there's a hole right here. But as x equal 3, f of 3 is equal 3. Okay, so f at x equal 3, f of 3 is equal 3. Now we want to find, so f of 3 is equal to 3. How about the limit of x approaching to 3? So we are not talking about, what is output of the function f x equal 3, but we want to see when x approaching to 3, what is the graph approaching to? Okay, so when x is approaching to 3, isn't that the graph on the left side? The graph, the y value is approaching to here on the left side of the 3. When x approaching to 3 on the right side, isn't that the y value approaching to -1 on the right side? So we say the limit of x approaching to 3, f of x is -1. Okay, so this is how do we do limit. Limit is not about at what happened at the point. It's about what approaching at that point. Okay, so let's take a look at the second one. So I have the f of -1. In this case, f of -1 is undefined. You cannot say f of -1 is 1 because this is an open circle, so it's not defined. And we don't see any other point right here, so the function is undefined at x equal -1. So we can say undefined. How about at x approaching to 1? What is the y value approaching to? So at x approaching to -1 on the left side, the y value is approaching to 1 on the left side. And at x approaching to 1 on the right side, the y value approaching to 1 on the right side. So the limit of x approaching to -1 is 1. Okay, so that we talk about limits. So how about this one, f of 2? So what is f of 2? So as x equal 2, the y value is 1. So f of 2 is 1. We can say it's 1 because this is the closest circle. So the dot is indicate that the 2 is actually, the 2, f of 2 is actually the output of the function. Now for limit of x approaching to 2, so we're gonna have to take a look at when x approaching to 2 on the left side, y value approaching to 1. When x approaching to 2 on the right side, the y value is also approaching to 1. So this is actually 1. Okay, so limit is about approaching. And the limits will be equal to a certain number when the approaching on the left side and the right side is the same. Okay, so if they are different, then we will not say the limit exists. So for example, limit existent on one side and one side limit. Consider the graph below here. When I have 1 to 5, what is the limit of x approaching to 1? F of x, right? So when I approaching to 1 on the left side, my y value approaching to 1 as well. And when x approaching to 1 on the right side, my y value approaching to 3. So on the left side and the right side have two different limits. Then how do we know what is the limit of x approaching to 1? So this one we will say does not exist because the limit on the left side and the right side is different. And we can always write one side limit as limit of x approaching to 1 on the left. The negative on the top of the 1 indicates that the graph is approaching from the left side until it hit the 1 for the x and the y value is 1. Limit of x approaching to 1 on the right side with the plus will be what? When it's approaching on the right side, the y value is actually 3. So 3. So when the limit on the left side and the right side is not equal to each other, we say the limit at that point does not exist.